BD can be written as C cos B and CD can be written as B cos C. So I was telling that we can write yes, we can write BC in terms of BD and CD. We can write BC in terms of BD and CD. So which means BC, length of BC is A. So I wrote this length as A. So A is equal to BD. BD is nothing but this length. So BD is C cos B and CD is B cos C, because if we take the projection of this length on this, so this will become B cos C. So if we add these two lengths, so we get the length of the desired side. I wanted to find the length of this side, so I got A is equal to C cos B plus B cos C. Similarly, B we can write as C cos A plus A cos C, and C we can write as A cos B plus B cos A. Okay, B I wrote as C cos A plus A cos C, and C I wrote as A cos B plus B cos C. So this formula is called as projection rule of the triangle. This formula is known as projection rule of the triangle. Okay. Now continuing ahead, I told you about sine rule, I told you about cosine rule, I told you about projection rule. So then yes, Napier's analogy. Napier's formula is also one of the important formula when we come to like discussing rules of solution of triangle. So basically in Napier's formula, if suppose we have a triangle ABC, I have a triangle ABC. Now small a is opposite to capital A, small b is opposite to capital B, and small c is opposite to capital C. These are the standard notations we are talking about. Now if I want to write say tan of B minus C by 2, okay. So if I take tan of B minus C by 2, so I will take the sides corresponding to these two angles. So small b is corresponding to capital B and small c is corresponding to capital C. So for this we will get B minus C upon B plus C into cot of A by 2. Okay, so tan of B minus C by 2 can be written as B minus C upon B plus C into cot of A by 2. Similarly, we can write for other two angles also. Okay, so this is simple. I'll just prove it. Okay, so if we take the RHS of this formula, I will prove from RHS to LHS, because RHS is a difficult expression here. So I'll start from RHS. So B minus C upon B plus C into cot of A by 2. Now using sine rule, we can write B as 2r sine B. So B can be written as 2r sine B. C can be written as 2r sine C. Similarly, in the denominator, we can write B as 2r sine B, and C can be written as 2r sine C. So sine B plus sine C, and then cot of A by 2. Now 2r will get cancelled. So in the numerator, we will apply the formula of sine C minus sine D. So what is sine C minus sine D? Sine C minus sine D I can write as 2 cos B plus C by 2 into sine of B minus C by 2. Similarly, in the denominator we can say sine B plus sine C. If I apply the formula of sine C plus sine D, so 2 sine B plus C by 2 into cos of B minus C by 2. Okay, and this we will have the term cot A by 2. So cos by sine will become cot. So cot of B plus C by 2, and sine by cos will become tan. So tan of B minus C by 2. So cot of B plus C by 2 into tan of B minus C by 2, and this term is cot of A by 2. Now we know that A, B and C are angles of triangle. Therefore A plus B plus C is nothing but pi, which means I can write B plus C as pi minus A. Okay, so in this step only I am like making the changes. I can write B plus C as pi minus A. So this is cot of pi by 2 minus A by 2, which means if I take complementary, this will become tan of A by 2. So tan of A by 2 into tan of B minus C by 2 into cot of A by 2. So cot A by 2, tan A by 2 will get cancelled, and we will be left with the final term, which is tan of B minus A by 2. And that is what was the left hand side. that is what was the left hand side. So tan of b minus c by 2. So this is how you prove Napier's formula. Okay. So similarly we can like prove for, using the other two angles also. If suppose I want to prove for C and A. If I want to prove for C and A, so tan of C minus A by 2, I can write as C minus A upon C plus A into cot of B by 2. And if I want to prove for these two angles A and B, so I can write as tan of A minus B by 2 is equal to, take the corresponding sides to A and B, so A minus B upon A plus B, and then multiply it with cot of C by 2. Okay, multiply this is cot of C by 2. So tan C minus A by 2 I wrote as C minus A upon C plus A into cot B by 2. So same formula I am taking, but I just proved for one term and I am showing how we will take for the other two angles. And if I take A and B, so tan of A minus B by 2 I can write as A minus B upon A plus B into cot of C by 2. Okay. So this formula is called as Napier's formula. This is also an important formula for solution of triangle. Okay. And now if you talk about the area, for area of a triangle, so for area we have like different formula. First of all I express this in terms of smaller. We have different formulas related to area, but first I am taking it in terms of smaller, which means in radius. So if I multiply in radius in semi-perimeter, I get the area for a triangle. So if suppose this is the triangle ABC, okay, and we have the in center I, okay. So if I join I with the three vertices, I get the three triangles, this triangle, and this triangle. Now since this is the in center, this will become the center for the in circle of this triangle. If I draw the perpendicular, this length will be R and this length is A. Similarly, if I draw the perpendicular here, this length will be R, this length is B. If I draw the perpendicular, this length will be R and this length will be C. So area can be written as, area of the bigger triangle is sum of these three triangles, AIB, BIC and AIC. So area of AIC will be half R into C. Then area of this triangle will be half R into A. And then area of this triangle will be half R into B. Because you can say half and then product of base and height. So base is A, height is R. So half AR for this triangle, half BR for this triangle and half CR for this triangle. Now if you take R by 2 common from these three terms, in brackets you will get A plus B plus C, which is nothing but perimeter. So I can write A plus B plus C as 2S because S is the semi-perimeter. S is semi-perimeter, so I can write this as 2S. So R by 2 into 2S, 2 will get cancelled and we will get the answer for area as RS. R by 2 into 2S, 2 will get cancelled and we will get the formula for area as R into S. Okay, so this is how you prove when you need to prove area for triangle in terms of in radius and semi-perimeter. Okay. Then one more formula I will explain you, which is if I am trying to express the area in terms of sides of a triangle. So if suppose I have the triangle ABC like this. Now small a will be opposite to this, small b opposite to this, small c opposite to this. So if suppose I want to write the area of the triangle in terms of height and base. So what I will do, half base into height, correct? Base is A, this length is A and height is H. So area of this triangle we can write as half A into H. Now what you do, you try to express height either in terms of B or in terms of C. So if suppose I am trying to express in terms of B, so I will apply trigonometry in this triangle, in triangle ADC. So in triangle ADC, if I am applying trigonometry, sin C will be equal to H by B. Sin C is equal to H by B, which means H is equal to B sin C. Okay, sin C is equal to H by B, which means H is equal to B sin C. And now you substitute this value of H in this. So if I substitute this value of H in this, we will get AB sin C and then half will come here. Okay, so half AH and I am substituting H is equal to B sin C here. The formula we get is half AB into sin C. So basically area, if I want to write in terms of sides, what I need to do, half and then product of any two sides and then take the sine of the angle between them. So if suppose here I have taken A and B, I will take sine of C. Okay, if suppose I am taking half A into C, so between A and C we have angle B, so half AC sine of B. Okay, and if suppose I am taking half B into C, so half B into C and then in between angle is A, so I will take half BC sine of angle B. Okay, so this is how you prove like this. If I want to write express area in terms of sides of a triangle, so how this is how I need to prove. So delta I can say half AB sine C or half AC sine B or half BC into sine. Okay, and then one more formula I have. If I want to express the area in terms of circumradius of the triangle, which is capital R. Okay, so for that I will be using this formula only. So half AB into sine C I took, and suppose I want to take the product of three sides of the triangle. So for that what I need to do, I will write sine C in terms of C. So I already told you that in sine rule we have C upon sine C is equal to 2R, because it is 2 times the circumradius. So C upon sine C is equal to 2R, which means I can write sine C is equal to C by 2R. Correct? If C upon sine C is equal to 2R, which means I can write sine C. Then take this here and take 2R in the denominator. Sine C can be written as C by 2R, which means half AB and then C by 2R. So we get the formula for area of the triangle as ABC upon 4R. So this is also an important formula when I want to write the area in terms of circumradius. Okay, when I want to write the area in terms of circumradius, then I use this formula. Product of these three sides of the triangle A into B into C, and then divide it by 4 times the circumradius of the triangle. Okay, so I think it will be enough for this video, and then I'll keep uploading similar videos related to solution of triangle when we meet in the next session. Okay, so thanks for now. Okay, hello friends, welcome to Maths and Kida. This is my YouTube channel. Okay, so I'll be taking the first lecture for solution of triangle today, starting with this. Okay, so solution of triangles first lecture. Basically, solution of triangles denotes the different properties and different formulae related to what we can do in a triangle. Okay, so if we have a triangle, say ABC. Okay, so I'll start with the basic notations. Okay, so basic notations में we have a triangle which has 3 vertices, capital A, capital B, capital C. Now side opposite to capital A is denoted by small a, side opposite to capital B is denoted by small b, and side opposite to capital C is denoted by small c. Okay, delta denotes the area of the triangle. Delta denotes the area of the triangle. Okay, S is equal to semi-perimeter. S is equal to semi-perimeter. Semi-perimeter means perimeter divided by 2. Okay, semi-perimeter means perimeter divided by 2. So for perimeter we will add all the 3 sides of the triangle and then divide that by 2. Okay, and then we have 2 radiuses. First is the radius of the incircle. So if you draw a circle inside the triangle which touches all the 3 sides of the triangle, that is called the incircle. So radius of that is in radius, small r, in radius, also called as radius of incircle. Okay, radius of incircle is called as in radius. And if I draw a circle which is passing through the vertices of the triangle like this, if I draw a circle which is passing through the vertices of the triangle like this, that is called as circumcircle. So capital R is circumradius, which is the radius of the circumcircle of the triangle. Okay, capital R is circumradius, which is the radius of the circumcircle of the triangle. Okay, so these are the basic notations that we use for studying trigonometry inside a triangle. And then I will start with some rules or some laws which are related to solution of triangle. Okay, so the first rule that I can think of is sine rule. Okay, so basically, if we talk about sine rule, in sine rule we take the sides of the triangle and the sine of the angles opposite to the corresponding sides. So suppose this is the triangle ABC. Now small a is opposite to capital A, small b and small c. So a upon sine of angle A is equal to b upon sine of angle B. If I take A, I will take the opposite angle A, sine A. If I take B, I will take the opposite angle B, sine B. And if I take C, I will take the opposite angle C, so sine C is equal to 2r, means 2 times the circumradius. Okay, so this is called a sine rule. For any triangle, the ratio of the side and the sine of the angle opposite to the side. Okay, so A by sine A is equal to B by sine B is equal to C by sine C is equal to 2r, where capital R is circumradius of the triangle. Capital R is circumradius of the triangle. Okay, so this can be easily proved. इसको हम आसानी से प्रूव कर सकते हैं. अगर मैं इसमें perpendicular drop करता हूँ, if I drop a perpendicular say from A on the opposite side BC, okay, if I drop a perpendicular A on the opposite side BC, okay, now I apply trigonometry in this triangle. So if I apply trigonometry in this triangle, in triangle ABD, in triangle ABD, sine of angle B, if I take sine of this angle, this will be perpendicular upon hypotenuse. So H by C, which means H we can write as C sine B. Okay, sine of B is equal to perpendicular upon hypotenuse, so H by C, which means H we can write as C sine B. And if I apply trigonometry in this triangle, in triangle ADC, if I apply trigonometry in this triangle, sine of C is equal to perpendicular upon hypotenuse, so H by B, which means I can write H is equal to B sine C. Okay, so if I have taken two triangles, first case I took this triangle and second case I took this triangle, but for both the triangles height will remain the same because this is the length of this line segment AD. Okay, so which means from this is equation 1 and this is equation 2, so from equation 1 and 2 we can equate both of them. So from 1 and 2 we can equate both of them, which means B sine C I can write as C sine B. Okay, so sine B I can take in the denominator of this term and sine C I can take in the denominator of this term, which means B by sine B can be written as C by sine C. Okay, B by sine B can be written as C by sine C. Okay, and similarly if I draw the altitudes from this point B, I can relate A and C, and if I draw the altitude from this point, I can relate A and B. Okay, so overall we can get the formula like this: A upon sine A is equal to B upon sine B is equal to C upon sine C. Okay, now continuing forward with the rules, we come to the second rule, which is called as cosine rule. Okay, second rule, which is called as cosine rule. Okay, in cosine rule, if suppose I have triangle ABC, I have a triangle ABC. Okay, by standard notation, this will be small a, this will be small b, and this will be small c. Now this complete length is A. If I draw the perpendicular from A on BC, this length will be D. So this length I can write as B cos C, because this is projection of B on BC. Okay, this length is projection of B on BC. So if I multiply B with cos C, I can get this length as B cos C. Okay, and this length will be B sin C. This length will be B sin C. Again by trigonometry, because I am taking the perpendicular, so for this I will multiply sin C with B. So this length, if suppose this length is x, I can apply Pythagoras theorem in this triangle, in triangle ABD. In triangle ABD, I can apply Pythagoras theorem. Okay, so if we apply Pythagoras theorem, what do we get? X square means BD square, x square plus AD square. AD is what? B sin C. So b sin c का square is equal to this length c square. Okay, so x square plus this perpendicular is b sin c. b sin c का square is equal to hypotenuse का square c square. Okay, now x is nothing but a minus b cos c, because this length is b cos c and complete length is a. So we can get x by subtracting b cos c from a. Okay, so if I substitute x is equal to a minus b cos c, if I substitute x is equal to a minus b cos c plus b sin c whole square, I get c square on the right hand side. So a square minus 2ab cos c, then b square cos c, b square sin square c, it will become b square is equal to c square. Okay, here I applied the I took the square of this bracket, so a square then minus b cos c square means b square cos square c. If I combine b square cos square c with b square sin square c, I get b square, and then minus 2ab cos c. So on rearranging this term, I will get the formula as cos c is equal to a square plus b square minus c square upon 2ab. Okay, cos c is equal to a square plus b square minus c square upon 2ab, which means if we are taking the cos of any angle, we add the square of adjacent sides, then subtract the square of the opposite side. So adjacent sides is a and b, so we add the square a square plus b square, then subtract the square of the opposite side minus c square divided by 2ab. Similarly, if I want to say take the cos of a, so if I take cos of a, b square plus c square minus a square upon 2bc. Okay, and similarly you can write the formula for cos b. So this rule is called as cosine rule. What is this rule called? This rule is called as cosine rule. Okay. So these are the starting rules, starting formula when we come to when we speak in terms of solution of triangle. So I told you about sine rule and cosine rule. Then one more rule is there which is called as projection rule. Projection rule. Okay. So if we talk about projection rule, basically in projection rule we take the projections of two sides of the triangle and try to express the third side in terms of those lengths. So basically, if we take the standard notation, so small a will be opposite to capital A, small b opposite to capital B, and small c opposite to capital C. Okay, so if this length I am taking as A and this point is D. So if I want to write say small a in terms of C and B, so what I will do? I will try to express this length in terms of this length, and I will try to express this length in terms of this length. So for that I need to take projection. Okay, so this angle is B and this angle is C. So if I want to write this length BD, BD can be written as C cos B. BD can be written as C cos B. Similarly, if I want to write this length, so for that I will apply trigonometry in this triangle, triangle ACD. So CD can be written as B cos C. If I want to apply trigonometry in this triangle, CD can be written as B cos C, because if you take projection of this length on this, we need to multiply with cos C, and if I want to take projection of this on BC, we need to multiply with cos B. So BD will come out to be C cos B and CD will come out to be B cos C. Okay, now BC complete length is made up of these two line segments. BC is equal to BD plus CD. Now BC is nothing but A, because BC is the length of the triangle opposite to capital A, so BC is nothing but A. BD can be written as C